Welcome. We are Group 1 from the class of C5. Today, we would like to discuss a case study of the impact of groundwater-induced land subsidence on urban structures in Jakarta city. Land subsidence is the gradual settling of the Earth's surface due to movement or removal of subsurface materials. Land subsidence in Jakarta is a direct consequence of rapid urban development interacting with the fragile nature of the Earth's surface. Our objective is to analyze how groundwater extraction and surface loading have affected the structural integrity of Indonesia's capital city. Land subsidence is caused by excessive groundwater extraction, load of buildings and constructions, natural consolidation of alluvium, and tectonic activities. Data suggests that tectonic activities are the least dominant. The true crisis is caused by human activity, specifically excessive groundwater extraction, which triggers a sinking of the Earth's surface. Jakarta is a flat plain and is surrounded by natural and artificial rivers. Topographically, it is flat with 0 to 2 degrees on the north. The ground subsidence is made worse by the population density of over 20 million and urban development from 30% to 90% of cities' built-up area. This rapid urbanization has significantly reduced the green areas from 35% in the late 60s to 9.3% in the 2000s, which severely impacts the basin's rechargeability. On average, the city sinks about 3 to 10 centimeters every single year. However, in some areas, the ground is dropping by as much as 28 centimeters annually. To put into perspective, some parts of Jakarta have sunk a total of 4 meters since 1974. The coastal areas are hit the hardest because of the alluvium that compresses easily under the weight of the city. This has caused a lot of structural issues and risks in the urban areas that will be elaborated further in this video.
Next, we will analyze the causes of subsidence and frequently encountered issue. Firstly, differential settlement and building tilting. Subsidence in Jakarta exhibit high spatial variation which ranges from 1 cm per year to 28 cm per year, depending on the location. This uneven sinking causes different parts of the structure foundation to settle at different rates, leading to differential settlement. This results to tilting and sinking of buildings and the cracking of the permanent concrete structure. Second one is environmental system inversion. Subsidence causes a literal malfunction of the city's drainage and river system. In this case, as the ground sinks, rivers and drainage canals become lower than before, causing water to flow more slowly or stop flowing properly by gravity. In some areas, water may even flow backward during high tide. This increases the risk of the inland flooding and coastal flooding because rainwater and seawater cannot be drained efficiently. Lastly is long-term geological commitment. Research indicates that natural consolidation of Jakarta soft alluvial clay is a slow and ongoing process, and this is predicted to continue until the year of 2068. This means that even if all humans' intervention stop today, the city will continue to sink for centuries due to its geological foundation. So, to achieve deeper understanding, we must look at the contextual reasoning that goes beyond simple flooding. So, I have analyzed 3 different critical elements. The first one in terms of safety and structural context. The spatial variation in subsidence rates creates a high risk of differential settlement, which is more dangerous than uniform sinking. The issue here isn't just the depth of the sink, it's the spatial variation. The differential settlement causes invisible structural fatigue. When the building tilts, it compromises the integrity of underground utility, which is in this case the connection of the gas line and the sewage pipes, creating a silent risk of the explosion or contamination that isn't immediately visible at the surface. Second one is in terms of health and environmental context. Subsidence causes drainage system malfunction and the expansion of flooding areas. In a rapidly developing city like Jakarta, this flooding is compounded by high concentration of BOD and COD in rivers due to industrial and domestic waste disposal. This isn't just a flood, it's a permanent biological hazard that creates a long-term health crisis, moving beyond simple hygiene into systematic waterborne disease outbreak. Lastly is in terms of legal and cultural context. Legally, who is responsible when the ground itself disappears? As historic coastal areas are reclaimed by the sea, we face the permanent loss of cultural heritage sites in North Jakarta. Subsidence forces a total of re-evaluation of special development planning, as certain areas may become legally uninhabitable or unbuildable due to their high compressibility of soil and the risk of permanent seawater intrusion.
Hi and Assalamualaikum everyone. So for one part, I'm going to talk about the society and safety impacts. So from the first slide, it shows the several major urban risks caused by the land subsidence in Jakarta. First, we have an infrastructure damage that can be seen through cracks on the roads, building and drainage system due to the continuous ground settlement. Second, a lake subsidence increase a flood risk, especially in the coastal areas. Lower ground level makes Jakarta more vulnerable to the tidal flooding and poor drainage performance during heavy rainfall. And lastly, subsidence also creates a public risk such as unsafe living condition, health and sanitation problem, and disruption to the daily activities. Therefore, lake subsidence is not only an engineering issue but also a serious urban and society challenge. It shows the figure about the crackings on the building and also the cracks on the roads. Although the investigation found no significant building tightening, lake subsidence still creates a major safety concern in the Jakarta. According to the study, continuous ground settlement has caused a cracks on the road and building structure. This damage may weaken infrastructure performance and increase the accident risk for the public. In addition, subsidence contributes to the flooding problems because lower ground levels make the urban area more vulnerable to the tidal inundation and heavy rainfall. Over time, this issue can disrupt transportation system, reduce the infrastructure reliability, and increase the maintenance cost for the city. Therefore, even without the severe structure tightening, land subsidence still represent a serious urban safety risk. Lastly, besides infrastructure and flood risk, land subsidence also creates a social and economic consequence for the urban community. One major social impact is the public fear and anxiety regarding because of the building safety. When people notice the cracks, flooding, or ground settlement, confidence in infrastructure gradually decreases. In some cases, community may experience disruption to the daily activities, especially when the road becomes damaged or flooded. This can affect the transportation, business activities, and overall quality of life. Economical, land subsidence also leads to the high repair and maintenance costs for the building, roads, and drainage system. Some buildings may become abandoned because they are considered unsafe or no longer suitable for use. Therefore, the impacts of the land subsidence are not only physical but also affect the social well-being and economical stability of the urban areas.
To reduce land subsidence and structural instability in Jakarta, several sustainable engineering solutions can be implemented. The first solution is ground improvement techniques such as grouting, soil stabilization, and deep soil mixing. This method will help to strengthen the weak soil layers and reduce the uneven settlement beneath the building. Another important solution is by controlling the excessive groundwater extraction. The excessive groundwater pumping is one of the major causes of land subsidence in Jakarta because it causes the soil compression and ground settlement. Therefore, by reducing the groundwater usage and improving the public water supply system are important in order to reduce the subsidence. In addition, the deep foundation system such as pile foundation can be used for high-rise building. Pile foundation transfer the structural loads to the deeper and stronger soil layers, which will help to reduce the differential settlement and also improve the structural stability. Lastly, by monitoring an early detection system such as INSA satellite monitoring and ground sensor can help the engineers to detect the land movement early and prevent the severe structural damage. Besides engineering solution, the strong regulation and sustainable urban planning are also important in managing the land subsidence in Jakarta. The government should enforce the stricter groundwater extraction policy in order to reduce the excessive pumping activities. Regular geotechnical assessment should also be included in the high-risk areas in order to monitor the soil condition and the structural safety. In addition, government monitoring program and sustainable urban planning can help to reduce the long-term infrastructure damage and also to support the safer urban development. This action will support the sustainable development and help to protect the urban infrastructure and public safety in the long term. Therefore, the cooperation between the engineers, authorities and the public is essential in order to ensure the long-term sustainability and public safety. Hence, next I will pass to Nurin Salsabila.
Now, I will evaluate the societal and environmental implications as well as the challenges and long-term impacts of the proposed engineering solutions. The first proposed solution is spatial analysis and groundwater management. By using GIS and GPS subsidence data, high-risk sedimentary areas can be identified and prioritized for pipe water supply, while controlled groundwater extraction is allowed only in more stable volcanic regions. As you guys can see from the slide, there's an example of GIS output which help us to make a better planning for controlled groundwater extraction according to the geological layer type data. This approach helps reduce land subsidence and supports long-term water sustainability. However, the implementations require high infrastructure and monitoring costs. Next is ground improvement. Among the proposed methods, deep soil mixing is considered the most suitable because it strengthens deep soil layers and reduces long-term settlement beneath high-rise buildings, as compared to grouting, which is only suitable for cracks and not large-scale subsidence, and for soil stabilization is only good for near surface but less effective for deep groundwater related settlement. So, however, the methods requires heavy machinery, skill expertise and high construction costs. And also it contribute carbon emissions from cement usage during the mixing process. The third solution is deep foundation systems. Although deep foundation improves structural stability in subsidence prone areas, deep excavation and dewatering during foundation pit construction may disturb groundwater condition and trigger additional ground settlement. Improper groundwater control can also cause piping and instability around the foundation pit. Therefore, continuous groundwater monitoring and preventive geotechnical measures are necessary to ensure safe and sustainable construction. Lastly, monitoring and early detection systems such as first one, INSA satellite, which is effective for large-scale land subsidence monitoring, while ground sensors provide more accurate real-time data at specific locations. By combining both systems can improve early detections and risk management. However, this system requires high installation costs, skilled experts, and continuous maintenance. In conclusion, land subsidence is a serious issue that affects buildings and infrastructure in Jakarta. Although engineering solutions can help reduce building tilting and damage, each solution still involves technical, environmental, and economic challenges. Therefore, all proposed solutions must take into account to overcome ground subsidence problem. So that's all from us. Thank you.